Hello, this is Mr. Huff, and I wanted to talk about metalloids a little bit. So, metalloids are those elements on the periodic table that can act a little bit like a metal and they act a little bit like a non-metal. They're not really a metal, usually because they're not malleable, but they are shiny. And they are not like a non-metal because they can usually conduct electricity a little bit. So, in certain conditions. So, let's take a look at these. The first column we see in the metalloids is the boron group. You can see here that boron is the top and it's followed by 4 metals: aluminum, gallium, indium, and thallium. Okay, so boron is used in laundry cleaners like borax. Boric acid is used as an antiseptic to clean wounds, and it also is mixed in to dope glass to make it heat resistant. Aluminum in this group is interesting because it is a light and strong metal. When aluminum was first discovered, it was actually worth more than gold. But now we've got the process of manufacturing it down so well that it's very, very cheap, and we use it for cans and foil wrap and all kinds of like temporary just throwaway things. Gallium is used a lot in electronic components, and indium and thallium are both rare metals. In the carbon group, the next group, you have 4 electrons in the outer shell, which makes them act a little strange because they can either try to give up 4 electrons to become stable or gain 4 electrons to try to become stable. It is a non-metal. And then we see, after carbon, we see silicon and germanium, which are metalloids, and then the last 2 on that column are metals. And carbon occurs in just about everything that is associated with biology. Organic chemistry is based on carbon. Most of the molecules in your body are some sort of hydrocarbon chain with carbon and hydrogen and oxygen stuck together in different ways. This is organic chemistry, and we won't be talking much about that at all. But there's carbon. Allotropes, and we've talked about this a couple of times, is when you have an element that can take different forms. Carbon we've talked about the most because you can see it as diamonds, which are really impressive. Graphite, which is the same atoms, but it's completely different than diamond. And Buckminster fullerenes. Those are all carbon allotropes. Also, we talked about carbon nanotubes. That's another kind of allotrope. Graphite is carbon, and it makes little flat sheets. It's a hexagon pattern. And because they're little flat sheets, they slide across each other very easily. This makes the carbon form when it's graphite. That makes it a good lubricant that is also dry. Diamond, if you look at this crystal structure here, you actually see a little triangular pattern. So it's like a triangular crystal. Because it's a triangle, that's about as strong of a structure as you can get, and that's why diamonds are extremely strong. So this is a crystalline structure that is for diamond, and light can pass through this, and it's very sparkly, and we like that. Buckminster fullerene is about 60 carbon atoms joined to make a very tiny molecular soccer ball, and they have some very interesting properties. This is also what they use to make, this idea here is what they use to make the carbon nanotubes. Silicon and germanium are both semiconductors, and these are the 2 most commonly used elements in electronics applications. So without these 2 elements, you wouldn't have your cell phones, and that's all we're going to talk about there. All right. Tin and lead, these have been used for a very long time for coating other metals and preventing corrosion. Tin is mixed with other metals to make bronze and pewter. And then lead was used a lot in paint up until a few decades ago. The problem is lead, if you are in contact with lead paint a lot, it's actually toxic. It can build up in your body and poison you. The nitrogen group, this is the group that's missing 3 electrons in the outer shell. And if you look at this, it's 2 nonmetals, 2 metalloids, and 1 metal. Nitrogen and phosphorus. Phosphorus is used to make matches and fertilizer. It's used in China. Antimony is a metalloid and bismuth is a metal, and both of these can be mixed with other metals to make the melting point of that metal much lower. This is usually it's a bismuth alloy that you see where you can have that metal that melts when it touches your hand. The oxygen group is missing 2 electrons in the outer shell, and that means it wants to pick up 2 extra electrons. The smell you smell when lightning strikes is ozone, and that's where you have not a diatomic but a triatomic, where 3 oxygen atoms are stuck together. And water is based on hydrogen and oxygen, and everything in the world needs that to live. Sulfur is interesting in that it has several allotropes. We haven't talked about them so much, but I've shown you pictures in class of the different structures that it has. And so other stuff in 16, we won't talk about that as much. We'll move on. Synthetic elements. These are things that are man-made, like technetium and promethium. Why would we want to make synthetic elements? Well, we're trying to understand how atoms work, but they're interesting because usually they're radioactive. They try to come apart very easily, and that lets them emit different kinds of radiation. And technetium, for instance, is used in many medical applications. But the most important thing is we understand how, by watching the atoms come apart, we understand how atoms go together, so that helps us. Transuranium elements. These are the bottom row of the periodic table. You'll notice that all of these are in parentheses, meaning that they're man-made. And they have their own kind of group. They should be metals if you look at where they're at on the periodic table, and if you call them a metal, that's going to be fine. But they have behaviors like metals, nonmetals, and metalloids. They have a lot of different strange behaviors. Because they disintegrate quickly, they're hard to study, so only a few people in the world get a chance to study those. And that's all we have to say.